Hey everybody, it's Norm from Tested, and I am so thrilled to have two guests here in our studio today. This is Bar and Hannah. You guys work on Maslow, right? The Maslow CNC device, which is right behind us. This is one of the biggest things we've brought to our studio ever. And Bar, can you explain what is Maslow?
So Maslow is a open source 4x8 foot CNC router. It comes as a kit, and basically our goal is to make CNC routing, especially big CNC routing, accessible to everyone. And we knew we needed to have it be 4 foot by 8 foot to work with plywood in its like native form, and we also knew it had to be affordable and affordable to ship. And so the whole thing is $350, and it ships in a box that's like yay big as a kit. And then you go to Home Depot and buy a sheet of plywood and some 2x4s and some bricks and put it together.
That's kind of mind-blowing because you said $350 in a box that you can get and assemble and then do amazing projects like this coat rack, which I am immediately in love with. Big fan of the Sutro Tower. And this was made on a Maslow.
Yeah.
Right? So I'd love to hear about the story of how this project came to be, because this isn't your first CNC device you guys have made. You also kickstarted the Smith, which is a desktop CNC. So what are your origins and why are you designing CNC machines?
So in college, I had a laser cutter. I worked in a lab that had a laser cutter, and I totally fell in love with like design something digitally and then watch it become real. And I wanted to have that sort of be accessible to more people. I wanted more people to have that experience. And so I did a desktop CNC router, did a Kickstarter for it. It was good. We shipped it on time, and I sort of ran out of things to make just because in that smaller sort of space, I realized that the things I wanted to build were really, furniture or, things that were human scale. And so I wanted to build a bigger machine, but the bigger machines that are out there are all in sort of the $15,000 to $100,000 range, and that just wasn't in my budget. And they also take up a tremendous amount of space because they're normally flat. So the goals for this project were that it had to fit in a one-car garage. Mm-hmm. It had to be under $500. What else was it?
Had to fit in the box.
Yeah.
Something you could ship.
It could ship.
Yeah.
Not more expensive to ship than it is to put the parts together.
Right.
Yeah.
And we hear that a lot from people who maybe are buying desktop CNCs or desktop laser cutters. They always want the bigger bed space, mm-hmm. right? Like those desktop machines are great to learn about vectors and design and to prototype and iterate fast. But if you want to build something like furniture, it's always really nice to have a really big canvas to work on. And the design of the Maslow is unlike, looking at other CNCs that are more bigger and more expensive, like you talked about. You all lay your 4x8 on a table. This is almost like on an easel. How did you guys end up on this kind of design to have it, and how does it work?
So how did we end up on this design was actually, so we're here for Maker Faire, and actually because we were at Maker Faire doing the desktop CNC router, and someone came up to our booth and we were just chatting, and he was like, I've always wanted to do an upright one so it wouldn't take up all the space in my garage. And I thought that was the coolest idea, and I just started thinking about once you go upright, if you take a regular CNC, you can flip it upright and it would still work. But you suddenly start to have gravity be a factor.
Absolutely.
And so if you make gravity work for you, you can basically use it to your advantage.
Well, let's take a look at the anatomy of this machine. I'd love if you guys could run me through exactly what's going on. It's clearly a 4x8 big sheet of ply, right? You guys bought it from Home Depot. But when I think of CNC, I think of like how many axes the machine has. Right? You need at least 2 to do something really interesting, 3 if you want Z depth. How does the 2-axis work? So X and Y.
It is a 3-axis machine. It's 2 by default, and then you can add a third if you want. Basically, what happens is these 2 motors are they're DC motors with a gearbox and an encoder, so they're very precise. We get very precise movement out of them, and it's a closed-loop control system. And these motors adjust the lengths of these chains, and by knowing the lengths of those chains very precisely, you can define exactly where the router ends up in your 4x8 sheet. So it's a little bit more complicated than your standard XY system, but same basic principle. You have 2 axes and you end up with 2 degrees of freedom.
And you want these chains to be extremely taut so you have that precision. The motors give you a lot of precision already. And then it's at a slight angle because you're also working against gravity. You don't want it to pop up. I actually noticed you have two big bricks attached to this carriage system here, which I guess push the router right against the board.
Yeah, that's exactly right. And those can be sort of any weight. We had a guy in Lao email us and he said, I can buy plywood, but I can't buy bricks. Can I make my own out of concrete?
Yeah.
And we were like, yeah, why not?
Wow. So in terms of setting this up, because we've been setting this up all morning, you said everything comes in a box. So there's the carriage. You have the bricks that your customers, your users supply their own weighted system. They supply their own router and end mills. And what comes in the box, I guess, and what do people have to put together?
The box is pretty much everything that you see that's metal minus the router, more or less. Obviously the motors are super important, the chains like we've been talking about, but then there's just a bunch of like small and larger pieces of hardware that keep everything in place. So even down to the wood screws that you see that are like holding the frame together, that's all part of the kit, what you get shipped.
So you get all the hardware, people provide their own 2x4s and their own, do you find that people now you're shipping them already, the people have designed their own stands for it, or is everyone pretty much using the designs that you guys have put out?
Oh yeah, no one follows our directions.
No one follows the directions.
I mean, some people do, but I'd say that most people end up redesigning the frame. There have been a couple people did hanging ones, so they can flip it up to the roof of their garage when they're not using it. Or against a wall so that, it's at a slight angle so you can just tilt it out a little bit.
Right.
People have done plasma cutter modifications. People have, it's open source with the goal of you can really take it and do whatever you want with it.
And you're actually mounting your material directly. Is it locked into the frame? It's there's like a jig that locks it into place. I imagine calibration is going to be really important, so it knows what part of the material you're cutting.
Yeah, so basically because the base is also 4x8, you can just clamp it with regular C-clamps to the edges. And the registration of this piece is actually not quite as critical. Having exact registration between this and the frame itself is very important. But if you shift this a little bit, it just shifts your cut. You don't get a distorted cut or anything weird and unexpected like that.
All right. Now, with this two-axis system, are your cuts more precise in certain parts of your material, like toward the center? Because if it's going toward the end, it's going to be more taxing on one motor than the other.
Yeah, that's a really good question. So I think our biggest thing that we didn't see as an issue going into before we started shipping, and it's actually a pretty big issue, is it has to very precisely know its dimensions in order to do the math, because it's very nonlinear. So we've been working through the process of how do you set it up and do some test cuts in order to make sure that your machine is precise everywhere. Mm-hmm. And where we are, so we're still in our beta phase, and our goal is sort of plus or minus a 64th of an inch across the whole 4x8 sheet. And right now we can do substantially better than that in kind of the middle region, but as you get like right up here, we're more like a 16th of an inch right now. But I think we'll get that figured out in the next couple weeks.
And is a lot of that just software improvements and just reworking the code and iterating?
Yeah, it's software improvements, and it's figuring out how to make it easy for people to enter, to get everything set up right. Because really the math doesn't need to change. It's just a matter, like when we first shipped, we were just like, we'll just measure your machine and enter the numbers. Mm-hmm. And that turned out not to be precise enough. So now we do this system, it wasn't even my idea, we're open source, so someone else in the community came up with this idea, that you take one of the chains and you string it from one motor to the other motor, and then it pulls itself tight, and then it knows exactly how far that distance is.
Yeah, right. You're using the exact same materials that it's using.
Yeah, you don't even need a tape measure.
Nice.
Yeah, exactly.
Wow. And then the interface itself. So you take vector files, SVG files, and do you have a piece of software that creates that work path?
Yeah. Well, bar programmed, our software is called Ground Control. But yeah, pretty much it takes in G-code files, which is like pretty much standard for all CNC machines. So you'll have to convert your SVG or whatever into G-code, and then Ground Control will read that and do the cut.
And I noticed that you have like the best version of the Maslow right now with your Z-axis. You have an optional, you have your dust collector. But this is something that people can just set up like in a garage. That was kind of the goal of this. If you have a garage that can fit a 4x8, you can make these big cuts and make some furniture.
That's the goal.
Well, we don't have the time to make a full chair today or one of these Sutro coat racks, even though I would really love one. But I'd love to see a test cut if possible.
Yeah.
Can we start this up and make something and see how it works?
Yeah, let's cut something out.
Awesome, let's do it.
So we're just going to open up an SVG file here. And so this is a sword.
Cool.
And
So right now you're in a web interface. This is a website called MakerCam.
yeah, this is a website called MakerCam, and basically, so the machine uses G-code, which is sort of the industry standard for controlling CNC routers, and we can work with pretty much any G-code source that you want. So if you already have you like using AutoCAD and their G-code or AutoCAD Fusion 360, you can just continue to use that. We recommend MakerCam because it's pretty straightforward. I think it works well.
And it's great for just these 2-axis designs.
Yeah, exactly,
Yeah, for
exactly.
security.
Perfect. So now we need to tell MakerCam a little bit of information about the machine itself, and so in order for it to cut. So the first thing we're going to do is select the thing we want to cut, and then just say we want to cut around the profile of it. So we'll tell it the size of bit we're going to use, which is 1/4 of an inch. We'll tell it how thick our wood is, which
0.389.
yeah, so let's just call it 0.45, just to
Yeah.
kind of give ourselves a little extra.
And I guess one of the advantages of this being upright is that there's no backing material that you're going to worry about cutting into. It just goes all the way through.
Yep, exactly.
awesome.
We do usually throw a piece of wasteboard behind it, a sheet of MDF or something like that, just to spare the machine from cutting it through. And then you just set how deep you want it to cut with each pass and how fast you want it to cut. And our machine is not as fast as something like a ShopBot. We're really not looking for like a production environment where you're like manufacturing something. It's sort of like a home hobby kind of environment. And so if we just tell it to calculate that path, let's see that now there's a green line just around the profile.
Yep.
So that's where we're going to cut. So it's offset by the width of the bit, just to make sure that your final part is the size of your SVG file rather than
Reduced in. Yep.
Yeah, compensates for the curve. And let's add some tabs to it just so that it stays in place. And now here in our software, you can see we were previously cutting some swords. We'll just open up that file, and there's our sword.
Awesome. And then within your software ground control, you can move where your start position is.
Yep.
This image right here is what the system knows about your board, right?
Yep, exactly.
And
So
that
this
was all
is
pre-calibrated.
Yep, exactly. And that's why we do a calibration step, so it knows where it is. And it remembers that between powering it on and off. So you really only have to do that one time when you set up the machine.
Is that so that you can use one sheet and just cut as many until you just have holes in it and have as many things cut out as possible?
Yeah.
Yeah, maximize that sheet. Will the system retain information of past cuts?
It does not. That's
okay.
kind of on our to-do list, though. It would be nice to have sort of a drop-down of here's all my sheets, because it knows where you've cut things from each sheet.
Right.
It would just be a matter of storing that information and letting you recall it.
Right, and not have to make those cuts again, but somehow visualize that on
Yeah.
screen to...
Exactly.
cool. Well-
And this is all of our software, our firmware, our hardware is completely open source. So we see a lot of our features are things that have been added by the community, because someone will want that, and they'll just make it and then add it, and then everyone gets to benefit.
Awesome. Well, I think we're ready to make our cut.
Perfect.
Let's get started. Okay, so about 20 minutes later, I see a very clear outline. That is a sword. Very cool. There are tabs here, which I know you designed as you're making the G-code. So to remove those, what's that process like?
So we're just going to cut those with a saw. In our shop, we usually use one of those vibrating saws for flush cutting. It works really well. You just zip, zip, zip. And then you can just sand those off if you don't want to leave any sort of mark.
Oh, very cool. Okay, so I'll let you do that. We can use any type of hand saw. Now, Hannah, when you guys have this set up in your shop, right? What's safety like? I'm sure that when you meet people at Maker Faire or when people are thinking about backing this and pre-ordering it, the question is, it looks pretty exposed. How does this compare to a different type of CNC?
Yeah, I mean, it's definitely comes up because it looks pretty kind of raw, you know. But really, what makes it even safer than most CNCs is the fact that this is all contained, and the bit spinning, you would really have to try to get in there and hit your fingers or something like that. And otherwise, I mean, it is heavier. There's some weight obviously in the bricks that you could drop something on your toe or something like that. But generally, we say it's really safe. Like, I've never hurt myself using it. I don't think we know that anyone has. So.
And this whole thing, like, this is a big thing. Yes, it'll fit in the garage, but if someone wanted to get the Maslow kit and maybe not have it cut a full 4x8, because you can go to a hardware store and get a 4x8 cut in half for you, is this configurable? Is it scalable to be smaller?
Yeah. The calibration process will fix all that for you. So if you say you want to just use half of this and have it be a 4x4 format, or even 2x2 is something that a lot of people ask about. It's really easy to just modify your frame, as long as you feel comfortable sort of changing the size of the frame, then the machine will do that for you.
Or you could even build a frame with that in mind and just have it be a smaller footprint if you wanted to do that. That's totally possible because it's open.
Yeah.
The
That's one of the
designs
advantages of
out
open
there,
source. Yeah.
and the people using the Maslow right now are already making their own versions, it looks like.
Oh, absolutely. Yeah, there's a huge community in our forums of people who are modifying it and doing their own, making it their own.
Wow, well, let's take a look at this piece. All right.
Yeah.
That is a routed sword. That's so cool. Yeah. This is going to be a huge hit at Maker Faire. I know it. She's going to walk up and want to walk away with swords.
We're a little bit worried about angry parents if we give their kids swords and it's not okay.
We have hearts too.
We have hearts and swords, and they have them make it themselves because it's all possible.
Yeah.
So what's next? Like, is the idea that you guys are going to keep on making these, keep improving it? What are the improvements going to be, and what are your long-term plans?
Yeah, so our real goal is just to push this idea, this technology. We love CNC, and we love the idea that people can make something digitally, share it with people around the world, and then have it become a reality as you take something digital and make it real. So we just want to push this technology and make it more accessible to more people. So it's not necessarily about us being the sort of sole providers of this kind of thing. We're open source because we want to see other companies take this idea and adapt it. We think that there's a ton of niche markets out there for people building different types of things that would want to modify the machine. For a lot of applications, this 2 horsepower router is just too big. So we look, ours is designed to cut plywood. You could build one that was designed to cut foam for making RC airplanes, or you can take it in a lot of different directions, which is something we're really excited to see people do.
Yeah, the scalability isn't just in the canvas size, it really also in the type of router you use, because you've done the hard work, which is the math of getting an upright CNC to work using gravity.
Yep, and when we did all of that, we designed it in such a way that it's easy to adapt to different things. So if you want to do a 50-foot one that goes across the side of a building and draws murals, it should be pretty plug and play to make that a reality. So we're really excited to see what people do with the open source technology that we're putting out there.
And for people who want to buy a Maslow, you can buy the box. It gets your flat rate shipping box, get all the hardware, and they can build one. When are you guys shipping if someone pre-orders like today?
That we're aiming to ship by the end of the summer. So we're doing August, September is kind of what we've been telling people. But yeah, if they ordered today, that would be hopefully by September they'd have their Maslow.
I would love to get one set up in my garage to test it, because something like this coat rack, I can't say enough great things about this. This is awesome. Like, it tells you exactly, like, I know the scope of what a laser cutter can do, what like a desktop CNC can do, but you can't make this unless you're cutting into large sheets of ply.
Absolutely.
Well, it's great to meet you guys. Thank you so much for coming to our studio, and we'll see you at Maker Faire.
See you at Maker Faire. Thank you so much for having us.
Thank you.